Hi, everybody. My name is Moshe Zadka, and I'm going to talk to you about how to build your Docker container with Docker. Your dog, we heard you like Docker, so we put some Docker in Docker so you can containerize while you containerize. So the motivation part, why are we doing that? So what do we want from a build system? So we'd like it to be portable. People sometimes like to work on their laptops, build stuff. People have all kinds of laptop needs. I'm like always the annoying guy who wants a Linux laptop. Sometimes they give me a Mac laptop. There's always this other annoying guy who likes like the Windows laptop. And of course you want the CI environment, which is going to be still different probably. So you'd like your build system to be portable. You'd really want your build system to be reproducible. If you build tomorrow, you probably want to build the same thing again. Especially if you only fixed one bug, it's really annoying to also deal with like, oh, suddenly we're using a different GCC. Hey, surprise. You'd like it to be fast. So I'm going to start by disappointing you all. Today I'm not going to tell you how to make it fast. Because that's how you write code, right? First you make it correct, then you make it faster. I'll kind of hint at like ways to optimize. But my usual bias is first make sure that the build system is trustworthy, and then start optimizing on top of that. So why do we use containers? Right, like this is a Docker meetup, but I'll still kind of, right, so they're portable, right? You run the same container on different environments, it runs the same way. They're self-contained, they have all the dependencies in them. Okay, wait, so this sounds like something we were talking about. So why we use containers as a build environment? They're portable, right? So you don't care what development environment you use, your container will run the same. And they're self-contained. So if your container has a certain version of GCC, or a certain version of Maven, or JavaC, or libSSL.so, or header files, whatever, it's all there. So, a little bit of kind of like how builds usually work. The bugs are mostly in your code. Yes, there are bugs in GCC. If you run into a bug in production, I have one promise to you, it's not a bug in GCC. It's your code. Right? GCC has seen a lot more usage than your code. But you want to manage your compiler updates, right? You don't want a new compiler because just different behaviors. The bugs are in your code, but they'll be exposed slightly different by the next version of GCC because of the optimizations. But you do want the compiler updates, because at some point, one of the developers will come and say, I really need the new feature in Go 1.8. I really need them. Otherwise, my life will be hell. So you want to manage them, but you still want to allow them pretty easily. So what I like to do is build a build container. Right, that container will not be running in the production system. Like, whatever you might use, OpenShift or Kubernetes with Helm or DCOS. This container will not be running there. This container will be running in your Jenkins and on your developer's laptop. So I don't really care if the build of that container is all that reproducible. So from CentOS colon 7, no specific version, and then like yum update and yum install and all of these things that kind of horrify me when I'm talking about the containers that run in the production environment. And the entry point will be a script called inside build. And why inside? Because we have a script called outside build, and I like to name them exactly that way to kind of distinguish them. So outside build is a very, very simple script. Oh, no, this is not outside build. This is build. Yes, outside build will be different. So build, the only thing it does that's like interesting is it captures the current date to a second level, and then it builds the right image. And sometimes at the end of it, it'll also push the image to like whatever registry you use. I didn't want to kind of confuse you with like the pushing part. But this is like basically literally the script. This is not like a prototype for a script. This is literally the script to use. And the idea is that like it builds a container with yum, and maybe it also does curl pipe bash and grabs the Go build system and the Rust build system and the JavaScript build system that you use together with whatever JavaScript tools are hot right now to build JavaScript things. And then it builds that image, and it ideally pushes it to some registry. Now notice that if you run the script 5 seconds from now, you will get different things. Partly because I'm pretty sure that like whoever does JavaScript build stuff uploads a new version of that every 5 seconds, and partly because the image will be different, right? Because the image will be 5 seconds from now. And that's fine. So every time we run this script, we literally push a new version of the image. That's fine. This is a feature, not a bug. So now we have a good container, right? It's easy to update, right? Like when the people really want Go 1.8, you just run the build, it grabs Go 1.8, probably a new version of the JavaScript packaging tools and so on. But now we want to build a Docker container from that. And if you want to run it from that build container, you'll face a problem that you want to run Docker from Docker. There's a naive way to do it, and that's the wrong way to do it. But funnily enough, there's 2 wrong ways to do it. So one is to run a Docker daemon in your thing that has the ephemeral container image cache, right? So Docker has an image cache that's really useful because most Docker images are like, you know, it's better than VM images, still pretty bad. Like 100 megabyte, 200 megabyte, not unheard of. You probably want to cache that. An ephemeral cache is just not a cache. It's just nothing, right? If you throw away your cache data, it's not a cache, it will just re-download. Re-downloading 200 megabytes every time you build gets old really fast. So you say, oh, I'll use like the outside container image cache, right? We already have 2 Docker daemons sharing the same container image cache is really bad news. The only thing worse than a non-existent cache is a corrupt cache. That's what you get, so not good. I feel like, you know what, I'll just build the artifacts from Docker, and then I'll build my Docker thing from the outside. That makes your build environment much more complicated. So you really want to try and run Docker from Docker. And the trick is to use, I think the official term I found on blogs is sister containers, which is a term I really like, so I'll use it. So Docker is a server, right? That's like slightly different than, say, how Rocket works, right? Docker is basically a server called containerd inside. And when you do Docker run, you don't actually run your container, right? I'm sure people know, but maybe I'll kind of just stress these points to make sure that people understand how this works, right? So when you do Docker run, you do not run your containers. What you do is you connect to a daemon that's by default local to your machine, but it can also be on the other side of the ocean, and ask it very politely to run this image for you. That has some downsides, but that has some upsides, and in any case, this is how it works. And the way it works locally is that you don't want to connect over TCP because security, blah, blah, blah. So there's a socket called /var/run/docker.sock. And this is like an immutable fact of every Docker version since like a long time ago, before I was using Docker at any rate. And it doesn't matter how you run your Docker, right? It doesn't matter if it's running in a virtualized environment in a Mac with like Docker for Mac or with Docker for Windows or like in any of the ways it runs. It will always be /var/run/docker.sock. So you mount it. It's a file. It's the Unix domain socket. So, and Unix everything in the file, you can just mount it into your Docker container. Now, you don't even need privileged containers for that. Literally, all you need is to mount that socket. Once you mount that socket, your Docker container will have access to the Docker daemon that ran it, which means it can ask to run other containers. That is pretty nifty because now there's only one Docker daemon, but a lot of Docker clients as Docker is meant to be used. So this is great. This is the right way to run Docker from Docker. So the build script is slightly more complicated. But the Docker file for the build script is very, very simple, right? So I used the data I was originally supposed to give that talk. But I guess we moved the meetup. So that's the data I still have in my slides, 2017. But assume that I ran the build process exactly the time that the meetup was supposed to have started. And then all you do in the container is copy /src. Now there's a few ways to move the sources over to a container. This is my favorite because it is reasonably fast. And if you do anything, like there's different ways that build scripts can run, right? And obviously, like we are kind of writing the high-level script that will actually run your makefile, that runs your Maven, that runs whatever. And you never know if something along the way kind of puts kind of leftovers in s/src. You try not to do it, you try to git ignore it. This way you don't have to worry about your git ignore files, right? Because this will make sure that like every internal artifact, intermediate thing, will just be in the container that is gonna go away very fast. And we'll see it going away really fast in a second, right? So this is the script called outside build, right? So there's 3 build scripts. Build, which we have already incarnated, builds the build container. Outside build runs the build container. And literally that's all it does. Again, this is the entire script. Like later on I'll have inside build, which I'll make, well, I don't know what you're actually doing, like, in build, maybe you're using Go, maybe you're using Java, but this script is literally the entire contents of the script. And the only interesting thing, well, I guess there's 2 interesting things about it, but the most important thing is that, I've been talking for too long without switching slides. So I'm sorry about that. Should have. Okay, cool. So it has the var run docker.sock, which is literally a constant because it is a constant. Then the mount is just, I usually wouldn't write it this way. This is like some tricks I used to fit code on a slide. So anyway, but this works. This is literally valid Python code that will work. You basically build a temp builder, which is literally just a build container, which, as you might remember, the entry point is /src/inside build. And it runs it with --rm -it. The argument that everybody who kind of like debugs Docker containers does so well. Anyway, so this --rm literally fulfills the promise I made to you at the beginning of the slide. Everything that this creates as an intermediate form will be destroyed by the end, right? Because that's literally the meaning of --rm. So we're good on that. Okay, so now a little bit of an interlude before we move to the next part of the build script. So you notice that the outside build is like amazingly short for build script. It's like literally 4 lines and 2 of them are calculating constants. It's pretty portable. I wrote it in Python. I could have written it in Bash. It's like really, like doesn't import any special modules, any OS level stuff, nothing. And in the worst case, it's re-implementable, right? Because it's literally 4 lines. So if you need to re-implement it in PowerShell for the Windows person, you can re-implement it. It's like literally 4 lines. All they do is calculate var run docker.sock twice. So if you have halfway decent string concatenation in your language, you can probably do that. So if you need to re-implement it because you don't have the right version of Python or something like that, that's fine. You can do that. One thing I missed from the build script is --net equals none. But in my real build script, I did not miss it. That was actually an essential part. So --net equals none means that your entire build process will work without connection to the network. So if something tries to do go get, or pip install, or yum install, or something that calls something, that calls something, that calls the Ruby script, that calls the Perl script, that somehow reaches out to the internet, it will just fail right there and then. That's a feature, because otherwise it will fail 3 months from now when the person who runs the server that the Perl script, that the Ruby script runs, somehow goes away, right? AKA left pad. Or GitHub being down, or like any of the fun stuff that we always encounter because life, right? So basically to work around it, you vendor, right? So I'm not going to cover how to vendor. It's obviously different from language to language. This is how you made sure you vendored. Because most languages and most tools will try to be friendly, and if they don't find the vendor version, they'll try to reach into like the GitHub package repository, something. This will stop them from being helpful. I've struggled with it, and I actually had a problem in production where like this actually stopped something that gets something from this, exactly in that like way. So now the part 2 of the build script is inside build, which, as you remember, this was what the build container will run. And it can assume a consistent environment. It's always the same version of Python. Or if I had written it in Ruby, it's always the same version of Ruby, right? Because it did from a specific version of the build container. So if you run the same build from the same Git SHA, it will use the same container, which means it's the same version of Ruby. And then you do Go build, or Maven, or Pants, or, hey, yes?
Sorry, just a quick question while you were
sure.
net equal to non-topic. If you specify a port, does that port work?
Sorry?
If you have this, and then you specify a port.
What do you mean a port? -P is like for incoming traffic. Ideally, nothing connects to your build container, but I think it won't. I think it will literally disable all the network traffic. But I'm not sure why people want like things to connect to their network. But by the way, there's like other arguments than net equal none. You can actually like fine tune the network really finely. You can even plug in Docker with like something. Oh man, this is scary. Anyway, you can plug in Docker with things that will configure IP tables exactly the right way. Networking in Docker is like a whole different talk that I probably am not qualified to give. I only know how to disable networking in Docker. I'm very good at that. Very good at not doing networking in Docker. Anyway, after you run like the Go build Pants Maven thingy that you run to kind of transform your sources into something that a computer can actually run, you're into Docker, you're into containers, like, well, I'm gonna ship containers to my production environment. Great idea. So I called it runner because this is what will be running in production. And the coolest thing here is that I'm calculating the hash from Git, and I'm sticking that into my image. So I guess I'm like morally opposed to the whole concept of colon latest. Colon latest is a sickness that should be eradicated from the world. Because what does it mean latest, right? It's like so ephemeral, right? Like, hey, YOLO, if something comes up, just run it, see what happens. It'll be fun, right? Like, I don't like that kind of fun, right? I'm a very non-fun guy. So there's no latest. I literally had I think by, this was this is pretty much an approximation to the thing that was running in Cluster HQ. By the time we shut down, I think we had 300 or 400 hashes for the most popular containers. None of them was called latest. All of them was called colon and then 40 characters that are very opaque, but until someone actually finds a collision attack against SHA-1, ideally distinct. Anyway, so you copy stuff to the SRC and then you run Docker build. Now, Docker build is a very, very interesting beast. So I want to talk a little bit about how Docker build works, because you all run it, but I'm not sure if you noticed some of the subtleties about it. So the way Docker build works is it looks at the files under the directory that you specify, literally in this case /src, /src in the container. Then it sends over the Docker socket the entire contents of that directory over. It says, when I ask you for stuff, this is what you have. And then, if the Docker file mentions any of these files by name, the Docker daemon will happily work it. This is really neat because this is a way to get around of where do I put my intermediate files, so I'll put them in my Docker container. In your Docker container, that's fine. They will die soon, but not before the Docker daemon has a chance to synthesize them into a Docker container that you can then upload. And that's what you do, right? You do Docker build, and you specify the other Docker file, right? So we had the Docker file for building. This is a run.docker. This is, maybe your run.docker looks slightly different, but ideally it doesn't look that different from this. You want that Docker file to be as short as possible for several reasons. First, you really, really don't want any yum install there or stuff like that, because again, it's kind of YOLO. What's yum update? It's update to now. What's now, right? If I want the build tomorrow with a slightly different different Go script, I want that to be the only differences. So that's kind of good to have that Docker file be pretty short. And obviously, the less layers you have, the faster it will Docker pull it when Kubernetes tells it to pull from like somewhere else. So objectively, being short is good here. So what's missing from this build system? I kind of had to cut some things out for time reason, but I want to talk at least a little bit about them, kind of indicate how I would solve the problems that you might think exist with this system. So updating base RPMs, right? So if you notice, this is a security hole right here, right? Like, the next time there's a bug in any of the things that are in 7.2.511, this is a problem, right? Now I have a security hole. There's a few ways to approach the base RPM stuff, but before I go that, and then you probably thought, well, Go build is pretty fast, so you probably don't need to cache. But what if I build Scala stuff? Scala is like the slowest build ever, right? So you probably want to try and cache some like intermediate jars. How would you approach that? So like I said, like what I promised you today was correctness, not speed. But I want to indicate how I can solve the speed problem as well. So first, security, important, right? So basically, you can do a periodic rebuild. I did it from CentOS 7 to 5.11 here because I don't want to add like another layer. But you can easily have like kind of like an official base container for your company, and again have that its own kind of Docker repository and do it time-based. So you literally do yum update, push with time, the same strategy we use with the build container. And then again, like the from here is instead of from CentOS, from my awesome CentOS, : and then the time version. Again, if you build the same version, it will have the same security holes, which is a feature. If you want to fix security holes, you need to fix your source code. Not a complex fix, you just change the date. But you've done it. Someone wants a code review on that. Your QA team can know what you've done. They can figure out what happened. If somehow that injected a bug, you can figure out that this injected the bug because this is the only thing you changed. This is pretty nice. The other thing you can do is literally shove the RPMs into a Git repository and then run the Docker build from that repository based on hash. This is not nice because you should not push binary files to a Git repository. On the other hand, RPMs are like typically just on the side that Git kind of handles them okay. So if you put them in a dedicated Git repository, it kind of works. The trade-off to those approaches, the trade-off in the RPMs is that you need to re-vendor explicitly, but you build from a Git and you can easily see what versions you've done. Those trade-offs, you can decide what's good for you, but my main point of showing you two solutions for this problem, this is not a hard problem to solve. This is just something that I didn't want to, again, show the script. I don't think it's a very deep problem. Caching is a more interesting problem. Luckily, we mostly had Go and Python stuff, so it wasn't like a big problem, but I did spend some time thinking about how I would solve it when it comes up. So you can ad hoc -v a cache directory. This is fine because cache is supposed to be a cache, right? You need to use a build system that is good about how it uses a cache. My favorite is Pants because it builds most systems, and it's one of the best in like using caches because it's built by Twitter. Twitter has a lot of code in Scala. As I mentioned, Scala is super slow to build. So Pants is really, really good at using caches. So you can just -v a directory that. That at least will solve your main problem with the developers. Right? You just -v a cache directory. If you ever run into problems, you just nuke the cache and rebuild, and it's a cache, so that's fine. So you can solve like, I guess, 70% of your problem, the problem of like developer, fast feedback for developer. People will still start complaining about your CI system, so that can usually be your entire solution. You can use a cache. You can use a cache that the CI creates, and then use it everywhere. It's probably pretty close because most people only change one small component. So the cache from the latest master build is probably good. If it's not, you probably have a bigger problem in your development process because why are people changing that much stuff in one branch? So that solution, again, sometimes works. You need to figure out a good distribution scheme, but there's like a lot available. And that depends a lot on the details of your CI and your dev environment. You can upload to a shared cloud storage. Like you can literally upload stuff to S3 and then have the beginning of the build grab stuff from S3. You probably want another layer of caching because grabbing stuff from S3 can be slow, so that kind of depends on size versus complication. Again, there's like a lot of solutions here. And like the reason I like transforming correctness problem into performance problem is because performance problem, if you solve 90% of the problem, you solve 90% of the problem. If your solution is only correct 90% of the time, it's no good. If the performance solves 90% of the problem and 1 out of 10 builds is slightly slower, people can usually live with that. So this is kind of all I have to say about caching. So kind of summary. So containers are pretty cool, right? This is like literally the easiest crowd to say that to. They're pretty cool as a build environment, right? This is like something I haven't seen done that often. Usually people are like, yeah, they're like good for like, deploying into the test environment or even deploying into staging, but people don't use them as much for build environments, and I think they should. So this is kind of the main message I've been trying to send out. They're obviously useful as build targets, right? They literally solve the whole problems with, the people from C Associates, obviously have like, kind of a long old system and they already had an artifact repository. But if you don't already have an artifact repository, managing an artifact repository is one of the least pleasant tasks of a CI team. Docker registries are a pretty good artifact registry if you kind of abuse them in exactly the right way. So this is why I just like, my entire build targets are just Docker containers. The only thing I know how to build are Docker containers. I shove them into registry. I understand how they work in registry. All the smart optimization of like storing like layers and all of that, Docker registries. It's pretty nifty when they have both, and like so that your CI team and your R&D team understand the same infrastructure and can speak in the same terms. But as is often the case with containers, they're kind of a new technology. So you probably want to build some amount of local tooling. Hopefully I've shown you like not a really big amount of local tooling, but one that will actually get your stuff to work. So I have some time for Q&A, right? I want to remind you that the question is something that you do not know the answer to. Okay, so any questions? Oh. No? You like earlier, like you have a question. So I'm really nice. I'm happy to answer questions. Okay, yes?
So when you're saying that you're installing Docker on Docker, you meant in a container in Docker, not installing the whole infrastructure, right?
Right, so I only run the Docker client from Docker. I do not run the Docker daemon from Docker. Hopefully I've kind of convinced people that it's a good idea to run the Docker client and a bad idea to run the Docker server in a container. Honestly, the only reason to run a Docker server in a container, and they actually worked a little bit to make it possible, but the only use in that is if you're actually developing the Docker server, because that is a nifty way to debug the Docker server. But unless you're actually one of the fairly small number of people who develop containerd, you probably should not be doing that. Yes?
Did you, after you introduced this, did you give a piece to developers? Like, what was the interaction between you as a central team and to developers, and did it make their life better?
So I hope so, but I'll tell you what I did, and then like I guess better is a very vague term. So basically, literally what I gave them was outside build, and I kind of gave them like the initial version of inside build, but I told them from now on they're managing inside build themselves. Because that made sense, right? Like if they needed to build another Go thing or exactly like specify, right? Like they also manage like their own Docker file that they managed. So, and this is slightly better than what I gave them. I learned a lot from like I guess their feedback and my, so this is kind of, if I had continued there, I'd like further improved. So this is like the kind of more improved, but like it's a good approximation for what we had. So basically outside build was kind of my responsibility and inside build was kind of their responsibility. The only case where they actually hacked outside build was it was a mutual agreement that they can temporarily disable minus minus net equals none until they figure out some of the details of vendoring. So there was like they did the comment out. I made sure there was a Jira TechNet ticket next to that said we have to re-enable it once we figure out. I think we kind of ran into just technical problems vendoring GoLint. Like the literal Go dependencies were vendored properly. GoLint was not vendored the right way. It actually caused problems in production. So once again, we accidentally used a newer version of GoLint that made all the builds fail because the new lint rules made them fail. So I kind of hope that this will convince them to kind of fix that problem. And I think they were going to fix it. Yeah, so this was like the only case where they hacked outside build. Otherwise, basically inside build was kind of, and further in was their tool. And obviously that was partly because I was a very small infrastructure team. Like I was the infrastructure team, and I had other things to do than build, so we kind of decided that this will be the area. You could put, other boundaries, right? I think the boundary I would have preferred was using a system like Pants or Bazel, and tells them that they run the Bazel configuration file and I manage the stuff in front of it. But Go is just easy enough to build with the native tools, and fast enough to build with the native tools that this was like a reasonable compromise. Yes?
So one of the problems to doing a bunch of jobs is that you tend to end up with the same user space at the end, as opposed to, say, changing the username, generating something new, creating a new user, and then using it to start all your processes and do all your installs inside a container. How do you ensure that your end user doesn't come out as a root for all of these?
So I'm not sure what you mean by end user. So we never ended up using user space mapping to run the Docker container, so they all ran as root. This was, I guess, in the plan. But this has nothing to do with the build, right? You can build the Docker container however you want, and then run root map to whatever user you want when you run it. So user space mapping is right, like I kind of literally covered only the build, right? Only the part that goes up to the registry, right? The only downloads from the registry for like the build containers. We not cover the other side, right? Like Kubernetes, OpenShift, Helm, Swarm, Mesos, Data Center OS, whatever you have on the other side. That's the layer you should solve the user space mapping problem at. It's usually okay to run the entire Docker container, like all the processes inside the Docker, it's the same user. Not necessarily all as root, right? You probably don't want the user space mapping. But if you find that like different processes inside the container need different users, you can do that. Usually, I find that this is an anti-pattern because it shows that your Docker container is too thick. You probably want to split it apart, especially if you're using something like Kubernetes that is pretty sophisticated and has pods. You can, again, pods are a way to run containers, right? I literally only covered, again, building, but you could build containers that kind of like, at runtime, the pods will kind of make them share the right stuff. So they, even your log rotator can run in the same pod and stuff like that. You can get pretty fancy with that stuff. So I really like to shift those problems to the runner, because then you can do a lot of nifty stuff, like running everything in root in your staging environment, so that everything is simple and you don't have to complicate it. Or maybe on your dev environment because you want staging to be more closer to production, but maybe kind of simplify the dev environment a bit. So it's kind of nice that you can make the distinction at runtime, and you don't have to worry about it at build time at all. Does that answer your question? I hope I kind of... Okay, awesome. Then I'm glad, because I wasn't sure I understood your question, but if I answered it, then I probably understood it reasonably well. Any other questions? Cool, thank you very much.